All right, this is a little bit of a spoiler for the next problem, but I want us to start to get the hang of what a u substitution can do for us when we were looking for an antiderivative. So remember what we learned about the chain rule. If I told you that f of x was equal to e to the cosine of x, and then I asked you to find f prime of x, well, f prime of x is going to be whatever base function this was. In this case, this is an e to the something problem. So it's going to be the same e to the something, because that's how we take the derivative of an exponential function. And then we would multiply by the derivative of the exponent. Well, the derivative of cosine x is negative sine of x. You might rewrite this, but this is not a big deal. So you might say negative sine of x times e to the cosine of x. And just notice that the result of a chain rule problem, result of taking the derivative by a chain rule, is always a product. This is the derivative of the outside with the inside the same times the derivative of the inside. So we're always going to have this multiplication here. So this is the real power of using a substitution to find an antiderivative, is if that function we're trying to find an antiderivative for is a product, if there's some kind of multiplication happening, then it's very likely that I can think of it as a result of taking a derivative using the chain rule, and then I'm going to use this use substitution to sort of undo the chain rule. So check out this next problem. So now when I want to evaluate this integral, sine of x times e to the cosine of x dx, I check. There's only one variable, so that's good. I have to think of, I notice that there's a product in my integral, sine of x times e to the cosine of x. If a substitution is going to be successful, that means that this integrand must have been the result of taking the derivative using the chain rule, which means that one of the factors in my integrand should be the function, and the other factor should be the derivative of the function. So in this case, one of these should be my u, or closely related. One of these should be a function of u, and one of these should be the derivative of u. So one way to think about it is if I thought of this, if I thought of separating this integrand between, like, on two sides of a multiplication dot, my choices are sine x and e to the cosine of x. So one of those is probably going to be my u, and the other then should be the derivative of u, or closely related, like within a constant of the e to the u, of du. So I'm going to use u to be cosine of x. That u, that should be like the inside when we thought of taking the derivative using the chain rule. So the derivative of the outside with the inside the same, it should be the inside. So I'm going to test this out. If I can write a new integral with this substitution that contains only one variable, then I've made a correct substitution. If using the u that you pick doesn't result in an integral that you can anti-differentiate and that only contains one variable, you got to try picking a different u. There are also some problems that cannot be evaluated using this technique, but all the ones you run into in this section in your assignments should be. So if u is cosine of x, then I need an expression for du is going to be derivative of cosine is negative sine of x dx. There's a couple ways to think about this. This is the